Automatic transfer switches, or ATS, are used to automatically switch a load from a primary power source to a backup power source when the primary source fails. To get up to speed quickly on this technology, consider several resources. Firstly, manufacturer manuals and technical documentation are crucial. Cummins, among other ATS manufacturers, provides comprehensive manuals that cover installation, operation, and troubleshooting. Secondly, online courses and training modules are available. Many manufacturers offer online training programs that provide a structured learning experience. Thirdly, industry trade journals and magazines offer insights. Publications such as Electrical Contractor, Electrical Wholesaling, and Power Engineering provide articles and case studies on ATS technology. Fourthly, webinars and conferences are useful. Industry organizations and manufacturers host webinars and conferences where experts share their knowledge and updates. To get your questions answered, you have several options. Firstly, contact manufacturer support. Cummins and other ATS manufacturers have dedicated support teams available to answer questions and provide technical assistance. Secondly, seek help from experienced professionals. Connect with electrical engineers, technicians, or contractors who have experience with industrial ATS systems. Thirdly, join industry forums and discussion groups. Participate in online forums and discussion groups where you can ask questions and engage with other professionals. Specific knowledge areas to focus on include firstly, ATS types and applications. Understand the different types of ATS such as open transition and closed transition and their appropriate applications. Secondly, diesel generator controls. Become familiar with the various control systems used in diesel generators integrated with ATS. Thirdly, load shedding and peak level control. Learn about the techniques used to manage electrical loads during power outages. Fourthly, electrical distribution. Understand how ATS are integrated into electrical distribution systems and the safety precautions involved. Fifthly, maintenance and troubleshooting. Gain knowledge about routine maintenance and troubleshooting procedures for ATS. It's important to set realistic goals. Don't try to learn everything at once. Focus on the most critical aspects and build your knowledge gradually. Hands-on experience with real-world ATS systems is invaluable for gaining a practical understanding. The technology surrounding ATS is constantly evolving, so stay informed by reading industry publications and attending training sessions. An automatic transfer switch is designed to provide a continuous supply of power by transferring a load from one power source to another. When the normal power source fails or experiences a voltage drop below a certain threshold, the ATS automatically switches the load to an alternate power source, such as a generator or a secondary utility feed. When the normal power is restored, the ATS automatically transfers the load back to the normal power source. There are several types of automatic transfer switches, each designed for different applications. Open transition transfer switches, also known as break-before-make transfer switches, momentarily interrupt power to the load during the transfer. This type of switch is commonly used when the backup power source is a generator, as it allows the generator to start up and stabilize before the load is connected. Closed transition transfer switches, also known as make-before-break transfer switches, momentarily connect both power sources to the load during the transfer. This type of switch is typically used in applications where a momentary interruption of power cannot be tolerated, such as in data centers or hospitals. Soft-loading transfer switches are a type of closed transition switch that gradually transfers the load from one power source to another, minimizing voltage transients and current surges. Static transfer switches use solid-state components to quickly transfer the load from one power source to another, typically within a fraction of a cycle. These switches are used in critical applications where even a momentary interruption of power is unacceptable. The selection of an appropriate ATS depends on the specific application requirements, including the type of load, the criticality of the load, and the available power sources. Automatic transfer switches are governed by various industry standards, including UL 1008, which specifies the requirements for transfer switch equipment, and NFPA 70, the National Electrical Code, which provides guidance on the installation and wiring of ATS systems. ATS systems typically include several key components, including the transfer switch itself, which is responsible for physically switching the load from one power source to another, a control panel, which monitors the power sources and controls the transfer switch, and sensing circuits, which detect voltage drops or power failures in the normal power source. Proper maintenance and testing are essential for ensuring the reliable operation of automatic transfer switches. Maintenance procedures typically include visual inspections, cleaning, lubrication, and testing of the transfer switch and control panel. Testing procedures typically involve simulating a power failure and verifying that the ATS automatically transfers the load to the alternate power source. Regular maintenance and testing can help to identify potential problems before they lead to a failure of the ATS. When selecting an automatic transfer switch, it is important to consider several factors, including the voltage and current rating of the switch, the type of load to be served, the transfer time required, and the available power sources. It is also important to consider the environmental conditions in which the switch will be installed, such as temperature, humidity, and altitude. The voltage and current rating of the switch must be sufficient to handle the maximum load that will be connected to the switch. The type of load to be served can also affect the selection of the switch. For example, inductive loads, such as motors, can generate voltage transients during switching, which can damage the switch. The transfer time required is the time it takes for the switch to transfer the load from one power source to another. In some applications, a very short transfer time is required to prevent disruption of critical loads. The available power sources can also affect the selection of the switch. For example, if the backup power source is a generator, the switch must be compatible with the generator's output voltage and frequency. The installation of an automatic transfer switch should be performed by qualified personnel in accordance with applicable codes and standards. The installation typically involves mounting the transfer switch, connecting the power sources and the load, and wiring the control panel. It is important to ensure that all connections are tight and that the wiring is properly sized to handle the load current. The control panel should be programmed to monitor the power sources and to control the transfer switch. The programming should be tested to ensure that the switch operates correctly in the event of a power failure. Troubleshooting automatic transfer switches can be challenging, as there are many potential causes of failure. Common problems include faulty sensing circuits, malfunctioning control panels, and damaged transfer switches. When troubleshooting an ATS, it is important to follow a systematic approach. Firstly, check the power sources to ensure that they are providing the correct voltage and frequency. Secondly, check the control panel to ensure that it is operating correctly. Thirdly, check the transfer switch to ensure that it is not damaged. If the problem cannot be identified, it may be necessary to consult with a qualified technician. Automatic transfer switches are an essential component of many electrical systems, providing a reliable backup power source in the event of a power failure. By understanding the different types of ATS, their applications, and their maintenance requirements, you can ensure that your ATS system operates reliably and provides the backup power you need. Always consult with qualified professionals and adhere to applicable codes and standards when working with electrical systems. Remember to energize equipment before performing maintenance or troubleshooting. Safety is paramount when working with electrical systems. Proper grounding is also essential for the safe and reliable operation of automatic transfer switches. The grounding system should be designed to provide a low impedance path for fault currents, minimizing the risk of electric shock and equipment damage. The grounding system should be inspected regularly to ensure that it is in good condition. Surge protection is another important consideration for automatic transfer switch systems. Surges can damage sensitive electronic equipment, including the control panel of the ATS. Surge protection devices should be installed on both the normal power source and the alternate power source to protect the ATS system from surges. When working with automatic transfer switches, it is important to be aware of the potential hazards involved. Electrical shock is a serious hazard, and it is essential to take precautions to avoid contact with live electrical parts. Always de-energize equipment before performing maintenance or troubleshooting. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout/tagout procedures to ensure that the equipment is not accidentally energized while it is being worked on. The NEC, specifically Article 700, covers emergency systems, including automatic transfer switches. This article provides requirements for the installation, wiring, and testing of emergency systems. It is important to be familiar with the requirements of Article 700 when working with automatic transfer switches in emergency systems. Article 701 covers legally required standby systems, which are systems that are required by law to provide power to certain loads, such as fire pumps and emergency lighting. Automatic transfer switches are often used in legally required standby systems. Article 702 covers optional standby systems, which are systems that provide power to loads that are not required by law to have backup power. Automatic transfer switches can be used in optional standby systems. When designing an automatic transfer switch system, it is important to consider the load characteristics of the loads that will be served by the system. Some loads, such as motors, can draw a large inrush current when they are started. This inrush current can overload the automatic transfer switch and cause it to fail. To prevent this, it may be necessary to use a soft starter or other device to limit the inrush current. It is also important to consider the harmonic content of the loads. Harmonic currents can cause overheating and other problems in electrical equipment. To mitigate the effects of harmonic currents, it may be necessary to use harmonic filters. The reliability of an automatic transfer switch system is critical, especially in applications where power failure can have serious consequences. To improve the reliability of an ATS system, it is important to use high-quality components to install the system correctly and to perform regular maintenance and testing. Redundant systems can also be used to improve reliability. A redundant system consists of two or more automatic transfer switches that are connected in parallel. If one switch fails, the other switch can take over and provide backup power. Remote monitoring and control of automatic transfer switches can be beneficial, especially in large facilities with many ATS systems. Remote monitoring allows you to monitor the status of the ATS systems from a central location. Remote control allows you to start and stop generators, transfer loads, and perform other functions remotely. This can save time and money and improve the overall efficiency of the electrical system. Automatic transfer switches are available in a variety of sizes and configurations. The size of the ATS is determined by the amount of current that it can carry. The configuration of the ATS is determined by the number of poles and the number of throws. A single-pole, single-throw SPST switch has one pole and one throw. A single-pole, double-throw SPDT switch has one pole and two throws. A double-pole, single-throw DPST switch has two poles and one throw. A double-pole, double-throw DPDT switch has two poles and two throws. The selection of the appropriate size and configuration of ATS depends on the specific application requirements. Automatic transfer switches are typically installed in electrical rooms or switchgear rooms. The location of the ATS should be easily accessible for maintenance and testing. The ATS should be protected from the elements such as rain, snow, and sunlight. The ATS should also be protected from physical damage. The cost of an automatic transfer switch system can vary depending on the size and configuration of the ATS, the installation costs, and the maintenance costs. The cost of an ATS system should be considered carefully when evaluating the overall cost of a backup power system. In summary, to effectively learn about automatic transfer switches, leverage manufacturer resources, online training, industry publications, and expert networks. Focus on understanding ATS types, generator controls, load management, electrical distribution integration, and maintenance procedures. Set realistic learning goals and prioritize hands-on experience. Stay updated with the latest technology developments in ATS.